Okay, so we've got the power supply
here's
set
what
on
we have a
12
little
volts.
closer.
This is the
Going
one
into
stator motor
the
that we were
SSG
running
circuit. I have a
on the other
ball hooked
video
up
with
to
the
output
Dremel tool.
because there will be some high voltage.
This time we're running it with the
let's
window
spin her
motor.
up.
You're in my way, buddy. You're in my way. You gonna help Daddy? Okay. I'll try to work around you. Oh, I always wanted to do this. Okay. I have here the same parts that I use for the video on Bedini high voltage without a DC power supply. How does this look? And I'll just set this down. I feel too silly with it. So here's the same motor that I used on the high voltage video, and I'm going to run it for a while on this window motor. I was using a Dremel before, as if you remember on the video. This way we'll keep some constant RPMs on the motor, and I'll take some measurements from it, and we'll look at how it operates as a generator. And the purpose of the video is that somewhere down the line I hope to clear things up a little bit. The other video was really confusing, and I apologize for that. So on this one we'll just go over some of that material again, if you don't mind watching and waiting and going through a long video. But we'll look at the window motor, running the stator motor as a generator. Then we'll look at the difference of running the Bedini SSG circuit, or simplified schoolgirl circuit, from a pulse circuit as opposed to mechanical oscillator circuit. And I hope to clear things up as to whether this is a motor, a generator, or a mechanical oscillator. Maybe by the time we're finished you'll say you can call it any of the three. So let me get some things ready and we'll get started. Well, first of all, we'll start looking at the components, and I'll try to explain them a little bit so that those who aren't familiar with the Bedini patents or his little circuits and what he intended them to do will understand a little bit better. So let me get something ready and we'll talk about it. So here's what we have a little closer. This is the one stator motor that we were running on the other video with the Dremel tool. This time we're running it with the window motor. The power for the window motor is 12 volts from the lambda power supply, and we're using the Bedini full wave bipolar circuit to run the window motor, although I'm only using one trigger, therefore half the circuit. We have the Bedini SSG circuit over here, and if you remember right, we've hooked this motor, generator, oscillator, whatever, to that circuit and ran high voltage spikes off the circuit and coils while turning this mechanically, as opposed to having a battery plugged into the SSG circuit, which would have been over here. So we're going to go back to that experiment later, but let me talk about the motors a little bit first. This is what these motors look like if you pull them off an office machine, or if you order them online. You can find these online if you type in a search for printer motors or office machine motors, printer drive motors, printer mains motors, anything like that, and you'll find these motors. I've seen them as low as $4. So what they have is a typical sort of an outrunner, like you see on a model airplane motor. They usually have some drive circuitry on them. These chips happen to be a NPN and PNP FET driver circuit, and there's usually some other components on there. But anyhow, these are, let's see here, wait a minute, let me go back to something else. When you start to take them apart, you get something that looks like this, a stator, a little casting here that holds bearings, and you can see that you almost already have a motor mount on there, I like these green ones because they have thin legs and you can wind a lot of wire around them, as you can see. The magnets for these are like a solid ring magnet around here, and they're actually 8 poles, 4 north and 4 south, if you measure them. So it's an 8 pole brushless motor. The way these motors actually work is there's some Hall effect sensors on the boards underneath the magnets, so they allow the motor to run in this 3-phase operation. If you look at the way the coils are wound, they're in a typical 3-phase configuration. Let me take one of these apart. It's hard to work with one hand. But this is what the windings look like on the stock motor. You can see under here somewhere there's some Hall effect sensors. I don't know if you can see one under there or not. I think you can. But there's 3. Looking at the back of the board, we can see the 3 beginning of the phases. This would be the beginning winding of each of the 3 phases. And over here we can see that each end of the 3 phases is tied together. So that indicates that this motor is in a Y or star configuration. And so it'll run as a 3-phase motor if you can figure out a way to do it. Now you can do that with a regular RC brushless motor control. So if you take those 3 wires, attach them to those 3 phases, get yourself a little servo tester here to run the speed control. You can run this as a brushless motor the way you would a model airplane motor. And I'm going to make a video about that at some other time, so I don't want to go into that too much. I'll pick some other motor and try to make something useful. There's some other things you can do with these motors. Here I've actually taken and made some connections to the Hall effect sensors that are under the rotor. So what I did is actually use the Hall effect sensor along with the John Bedini circuit and ran the motor that way. So there's a lot of things you can experiment with. The motors come in a lot of different sizes, shapes, forms. There's some pretty good size ones. That's a big one. And some of them even have gearboxes on them. Now what I usually do is melt this soft ring magnet off of here and replace it with something that looks more like this. And from there we're going to go on to trying out one of these motors and see what we have. So we'll get this running and hooked up and talk about that. I want to explain what started this whole experiment. At one time there was a lot of people on the forums taking these fans apart or buying a kit and rewinding this stator in here to work with the SSG circuit or a modified circuit of that, and they were making their little energizers or chargers or pulse motors this way. So I thought I'd try it, but the first thing I did was lose the bearing in the center, so I wasn't going to pick up another fan. So what I did was I had these other things, so I took one of these larger stator motors and I wound 4 of the legs similar to the fan motor. And that worked, so I thought, well, I sure would like to see if I could do it with all the legs. So that's how this started. I decided that I was going to do whatever I could to get one of these stators to work with all 12 legs wound. And the way I did that was the way I explained with trigger circuit and then the power coils. So to start this all off, I wanted to make a modified version of this and actually see if I could make a motor that would run from this little Bedini energizer circuit or pulse circuit. And so let's hook something up here and we'll take a look at it. Okay, so we've got the power supply set on 12 volts going into the SSG circuit. I have a bulb hooked up to the output because there will be some high voltage. And let's spin her up. Alright, so there you go. It's running up around somewhere between 3,000 and 4,000 RPMs. And it's pretty cool. I mean, so the motor works. It's weak, but don't forget it's got those little bitty magnets in there, and you could replace that with big ones and actually get some power off of it. I may do that somewhere down the line. You can see we've got some high voltage coming off of that, and yep, I can get a little pinch off of this, but it's wimpy. So that part of it was a success, and you know, that's what started the whole thing. Finding out that the circuit can be activated mechanically rather than with this power supply hooked up was an accident, and I just wanted to show it to my friends on the internet. So there you go. I think this is cool. This is a brushless motor running off the simplest circuit, one transistor circuit. So putting all else aside, this is worthwhile just in itself as far as I'm concerned. You can have a lot of fun with that. So let's go on to some of the other tests then. Okay, I'm going to try to take care of as many things as I can with this video. Before I use the scope for the next part of this project, this is for the guy who insisted for days that my videos were no good because I haven't showed that my scope is calibrated. So you can see the probe here is on ×1. The divisions are set at 1 volt per division, and the probe is hooked up to the standard, and so you can clearly see that there's 1 volt per division and a good square wave. So much for that. I'll hook this up and we'll do the motor test. At this point I've hooked the scope up to the windings that are on the 10 legs of the stator, which is my largest windings. And we have the window motor turning the stator motor generator oscillator at 1000 RPMs. I've adjusted to 13.9, 14 volts. And we'll go over to the scope and look at the pattern coming off of the motor right now. And I have the divisions set to 5 volts per division, if you can see that. So we're getting about 8 volts plus and 8 volts minus, or 16 volts peak to peak AC. It's not outstanding. It's kind of a small voltage, but remember, this stator here and the rotor, they're equipped with those little bitty tiny magnets, and my goal wasn't to make a strong generator. It had nothing to do with the experiment. It's doing just exactly what I expected. I'll show you a little bit more about this DC current in a second, or actually the AC. I'm going to rectify it and we'll take a look at it. Moving on, I've hooked a little bitty full wave bridge rectifier up to the motor and hooked the scope to the other side of that, and you get just exactly what you'd expect. Now everything is on the positive side, and so I've got a pulsating DC current that's about 8 volts. Now if I rectify that, I mean if I filter it with a capacitor, which I'll try to do with one hand, I'll just hold the capacitor across the output from the full wave, and as you can see, the trace goes up to about 7 volts and it's smooth. If I disconnect, you can see what happens. So there you see the pulsating DC being filtered to 8 volts. Now, do you think this 8 volts would charge a 12 volt battery? Not. And it's a far cry from 400 too, isn't it? So much for the concept that, oh, you can get high voltage anytime you spin a DC motor. Spin it and the voltage comes pouring out the other side. Not quite. Not when it's running like a conventional motor, generator like this is. You can see what it can do with this RPM. So now we're going to hook it up to the other circuit. Alright, so far what we have in this video is something that I was too dumb to explain in the other one, or didn't have enough time in a 10-minute video, is we can take a salvaged office printer or copier machine motor and turn it into a motor. It can be a 3-phase motor running from a 3-phase circuit of any kind, even a model airplane brushless speed control. It can be modified. The coils can be modified on it to run from a pulse circuit. The motor also can be used as a standard generator. Even though this is a weak one for a special purpose, it could be a generator. So now it's time to go on and explain the Bedini SSG circuit as best I can. I'm not an expert, but let's have a look at it and it'll help explain things a little bit. This is the SSG circuit. It was originally named the Simplified Schoolgirl circuit because it was introduced in a science project, and I think a young girl ran a crank generator, like old bell generator of some kind, as a motor for the length of the project on a 9-volt battery or something like that. I think they were probably charging something else as it was going. The circuit's very simple and inexpensive. It has one transistor and a few resistors, diodes, a little high voltage neon bulb there, and a little potentiometer for making adjustments to the circuit. Now people are using this circuit successfully to charge batteries. Let's put aside the radiant energy and everything for a minute, because I have no way to prove whether this particular device is running and successful because of radiant energy or not. I can't measure it. I can't say it does. I can't prove it one way or the other, and I'm not here to try to. But I can show you that it'll charge a battery just the way it is. First of all, I've left the power supply at 13.9 volts where it was to run the other setup because I don't want to change it. And I've hooked the scope up to the output of the SSG circuit, and it'll run as a motor. It'll take off again. But let me show you something. Nothing is going on when I rotate this at this speed. Now if I go a little faster, you can see this neon bulb flashing, which has the capability of blowing out my transistor. But do you think this generator, which is this motor, which is almost identical to this one, is putting out that high voltage because it's a standard generator? I don't think so. Same small magnets that you've seen before, and you can see it takes 90 volts to light that neon bulb. Now the scope over here has the probe set to times 10, which is in this back position by my thumbnail. I'm on 5 volts per division, which means times 10, every thing you see a division high is actually 50 volts. So when I give this these little pops, you can see the trace jumping up there. You know, that's probably several hundred volts. So this is sort of the standard operation of this circuit and some sort of an oscillator. Now this is the third part of this setup. Is the reason for the small magnets is I don't need to make a lot of voltage and current. I only need to make enough from this little trigger coil to fire this transistor, which drives the bigger coils in here and gets the motor into rotation. As it rotates, it becomes an oscillator, and the coils are turned on and off and pulsed with whatever current you have and voltage coming into the circuit. So if I spin this up, it's going to run and it'll charge something. I'll do that. 9 volts. I'll switch it back to where it was before we go on with the other experiments. What I need to be able to show you is that we can charge the 12-volt battery with less volts, like a 9-volt input to this SSG circuit. So let me just go back and show you that still, if I pop this, the high voltage is coming through even at 9 volts, and you can see it popping up there on the scope. At least I hope you can. So I'm going to hook the battery up and we'll take a look at it from there. I have this 12-volt battery, and you see it's plugged into the output of the SSG circuit. And over here I have the clips for the voltmeter on the battery. It's a 12.5516. So let's start this thing up and see if this 8 volts or 9 volts can actually charge this battery. So there you see the battery going up. Alright. Of course, the circuit here is not tuned. There's a spot, what they call a sweet spot in these circuits, where you can get an adjustment that's really gets the charge to accelerate. So anyhow, you can see it's not killer, but it's charging. But it's a big battery for this little circuit. I've used this to charge alkaline batteries, 9 volts, and little ones, and other small lead acid batteries. I'm not really into this because I don't have a big use for lead acid batteries. I'm a fan of LiPo technology. But anyhow, let's see what's really charging that. I'm going to go back to the scope again. I'll unplug this and hook the scope up. I'm still at 9 volts powering the SSG circuit, and I'm hooked back up to the scope again. So I'm going to start this up. And you can see the neon light is glowing solid here, and the scope trace is going high. I'm probably going to sacrifice this transistor for the sake of this experiment, but it'll be worth it. So anyhow, you can see the trace is actually completely off the screen, so that would have to be over 400 volts right now. And yeah, sure, everybody knows that there's no power behind this, there's no current, and it's not meant to have current. It's just meant to have this high voltage, and it's good for charging lead acid batteries. It'll recondition them and charge them, change the chemistry a little bit so they charge fast. And this can all be done without saying a word about over unity, or free energy, or radiant energy. It's just something that works. People are using it, and they're having a lot of fun with it. So let's go on to another part of the experiment. Alright, now we're going to get into some of this really highly technical stuff. This is going to be about the 555 timer circuit, which has been around since the caveman days of solid-state electronics. So this is a little 555 chip here, and it's in a circuit that's known as a motor control circuit, or a PWM circuit, pulse width modulation. And what happens here is if you're controlling a motor, you can change the speed by changing the pulse width. So if you're looking at the scope here, if I turn the pot, you can see the square wave on the top getting bigger or smaller. And when it gets bigger, it's turning your motor on for a longer time, or your light bulb or whatever, and it controls the speed or the potential that way, as opposed to changing the voltage, which has a different effect on your motor. It certainly doesn't run as strong. So if you look at what I'm doing here, if I turn this down, I have this little light bulb here, which is dim, and if I turn it up, as the pulse width changes, the bulb gets brighter. But there is a pulse, and you can change the rate of the pulse by changing capacitors and stuff like that. So what we're going to do is, rather than spinning this stator motor here, which created a pulse that was running this originally, I'm going to put the pulse from the solid state into this circuit, just to show you that this circuit is meant to run on a pulse. It won't run on anything else. So let me get that hooked up and we'll take a look. Here's what I've done. I've taken the output from this PWM or timer circuit. I've actually added a little MOSFET or FET transistor here, which bolsters the signal up a little bit. And I'm putting it into the SSG circuit, where the trigger from this oscillator was originally. I still have the coil part of the motor oscillator generator plugged into where it should be in the SSG circuit. I have the power supply off, which I'm going to turn on now. Hey, what ho! You can see that this does the same thing that the oscillator did. So right now I want to call this an oscillator. There's no trigger in there now, so it won't run. It'll probably just do that and stop, because the stator legs are energizing on and off, and there's some magnetism and eddy currents and stuff going on there. Different thing to talk about, but anyhow, so the scope is hooked up to the square wave circuit right now, and you can see that changing the pulse width has some different effects on how the circuit works. And if you think this won't charge, it'll charge. This is probably what I find to be one of the best ways to charge. Maybe I can hook that up for a second. We'll take a look. I've hooked the battery back up to the output of the SSG, and I have the meter hooked up to the battery again, and we're at 12.5632, whatever. And I'll turn on the power supply, which is still set at 9 volts. Yeah, sure. Just what I expected. And once again, so you're charging a 12-volt battery with 9.3 volts. And of course that'll continue to go up. So much for that. Now you can see that the Bedini circuit works from pulses, and it's capable of charging larger size batteries with less input than the battery itself. And I'm not saying that there's more coming out than going in. It's just simple pulse circuitry, and there's nothing unusual about that at all as far as I'm concerned. It's just something that works. Let's move on. Before we go on to more boring stuff, let's take a look at another oscillator of a kind. I mean, this is something that probably the younger guys haven't seen before, but I have a few of these. This is an old Ford ignition coil, and on the end of it is a mechanical oscillator. So what happens is this oscillator vibrates back and forth as the core moves a little reed and set of contacts, so on and off, and of course when it oscillates, that goes across another coil in there that has an awful lot of turns, and you get some high voltage. So let's take a look at that. So here you can see the oscillator running. Cool, huh? And on the top here are the high voltage terminals. And see if I can do this without getting knocked on my ass somewhere here. So, see what I'm getting at? In a way, this isn't a lot different than what's going on over here. A little more control over here, a little bit different. But there you have an oscillator opening and closing a coil that produces high voltage. Here you have an oscillator. It goes into the circuit, and the circuit turns the coils on and off. It's just a more sophisticated way of doing it. But this is mechanical, and that's mechanical. So at some point in time, this can be called a mechanical oscillator. At least I'll call it that. So let's go on with testing this out now. We're back to where I started on the other video, where I have the little stator device hooked up. That's better, stator device hooked up to the SSG circuit. And on the circuit I have the oscilloscope hooked up to the output. And on the input I have this little capacitor rather than a DC power supply or DC battery or anything else like that that's normally required to run this circuit and have high voltage come off. So once again, I'm back here at 14 volts. The motor will spin at 1,000 RPMs. So there we go. And you can see the neon bulb starting to light up. Let's look at the scope. Yeah, we're on times 10. Once again, oops, I'm on 2. Let's go to 5 volts per centimeter, and I'll turn this other light off so we can see better. But at any rate, I think you can see there that the spikes are a typical H wave like people are looking for on these energizers or Bedini circuits. And the high voltage spikes are way up there at, let's see, 50, 100, 200, 300, about 350 volts. While this is turning at 1,000 RPMs. Alright, so will that charge? I don't know. Let's take a look. Okay, I've disconnected the scope from the output of the SSG circuit, and I've plugged another battery in. And let's see what we're doing here. We're measuring 12.3121, and the stator device on this board is disconnected. And we're going to run the other smaller device, which has the same windings, with the motor. This motor, the circuit board, the voltage coming into it has nothing to do with what's going on here. This is simply now being supplied from anything that comes from the turning of this stator device. So let's get her going and see what happens. Oh, gotta turn it on. So here we go. And let's go to the battery voltage. Alright, it's pretty slow, but it is going up, you can see. I'll hook this other battery up here. This one is sort of depleted, and maybe it'll give a better example of charging without this input being hooked up to a battery or power supply. So let's get started here, and we'll look at this battery, and you can see it'll charge. Actually doing a pretty nice job. So anyhow, you get the idea there. You can see this is hooked up to the meter, to the output of the SSG, and there's nothing on the input of the SSG except for this capacitor, which is being sort of back charged. Remember, this is an input, so this is working without this being charged up ahead of time. It's just somehow feeds back through the circuit, and that's what I wanted to show my friends, and everything got kind of carried away on the other video, and I apologize once again for it being so confusing. To turn this mechanical device here into something that's going to charge faster, I would take each of the 10 coils and put a transistor on each coil, probably change some windings, and it would probably work better, but I don't know if I want to go through that trouble. I'm not that interested in charging lead-acid batteries. Nevertheless, it wasn't meant to work. This was just something that I found out by accident. So here's what the video was really about, besides the testing of the starter devices, was to show the people that I know on the forums that this circuit can actually be activated without a battery plugged into the input of the circuit. And what this supports is some of the theory that there's some potential coming back through the circuit from the coils that helps re-energize the battery, or makes the whole setup while it's running a little bit more efficient. How it's doing it, I'm not sure. You know, I have some ideas that it has something to do with the different phasing of the coils. I think one pulse probably runs the motor, and I think the other pulse in between the motor pulses somehow gets back to the battery and charges it. And it's the same thing it's doing here. It's charging this little capacitor as it runs. So the capacitor takes the place of the battery. But, you know, I thought it was significant enough to show to my friends. We're going to take one quick look at while this is running and producing something that may or may not be usable. I think that you'd have to work on it a little bit to actually turn this into some kind of a real-life application where you maybe spin this with a windmill, or I don't know, something else. But anyhow, let's take a look at why this is running. Hold on a minute, I'll hook something up here. So I hook a meter up to the capacitor here, and you can see the capacitor is almost 4 volts. So what's happening is, yeah, part of this is working as a generator right now, in the very basic term or sense of the word. So it has 4 volts coming back, and strangely enough it's coming back through the input. And so that's how we're charging up that capacitor, and basically then the whole circuit, I imagine, is working at 4 volts, which isn't an awful lot to get anything out of for charging. But remember, it was an accident. I found that out, and now that I know it, you know, maybe I'd rewind this stator to produce more voltage coming in, and there'd be more voltage coming out, but I don't know if it's worth it or not. So anyhow, you may have a better idea now of what the first movie was about, and what some of the parts of the circuitry are doing. And hey, you know, Let's call it anything you want to call it. If you want to call it a motor, it's a motor. If you want to call it a generator, it's a generator. If you want to call it an energizer, it's an energizer. Whatever. But okay, so there you have it. I hope that this video cleared things up a little bit, and be glad to talk about any part of it that you'd like. Let me just tell you one thing here. These circuits, the full wave circuit, the SSG circuit, you can find anywhere on YouTube. There's hundreds of people that have used them, and they have the drawings of the circuit. And you know, I can't post drawings on my site because I'm a YouTube partner, and I have to have permission from the people like John Bedini, and I don't think I'm ever going to get that. So I'm leaving the drawings off, but you can find them anywhere. Just type in SSG circuit or bipolar, sequential bipolar, Bedini coil, window motor circuit. Any of that stuff will get you there. The stator motors you can find on eBay. Just type in printer mains motor or printer drive motor, and you'll find some of those. So there you have it. How about you, Rem? You got anything to add besides snoring? I don't know. There's probably a lot of people out there snoring right now. Okay, everybody, thanks a lot for looking, and we'll see you the next time another video comes along. Take care.